Hi once again learners, sorry about that video, it just got cut off. Let's get back where we stopped off last. We said that this squared needs to be multiplied by this 3 here, b to the power 3 and h squared. So this squared is in effect this 3, effect this 2. I told you when you have a power outside your bracket like that, you multiply exponents. So 3 times 2 gave us 6. Talking about this b, right? It gave us 6. And 2 times 2 gave us 4. So we simplified that. Then this -1, the same story. This -1 needs to be multiplied on the top here and needs to be multiplied on the bottom. So what's happening? Alright, there we go. Alright, so let's put that in there. We would have a to the power of minus 2 over b to the power of minus 3. That's what we would have, right? Then we would also have thereafter we need our exponents to be positive. So our b to the -3 needs to go on top and becomes b to the positive 3. Then we've got a to the -2 needs to come to the bottom, a positive 2. Can we see that? So that is how they got this answer here. That's how we got this answer here, right? We simplified that to this. Then let's look at the next step. Now 4, okay, a to the power 4, a to the power 4 cancel off. Now many learners we taught this here, we figured out the easiest way to explain this is like this. Which is the biggest? See, we got a b and we got a b, right? Or we got division here. Same bases, when we divide same base, what happens to our exponent is that we subtract them. 6 minus 3 doesn't give us 3. That's how we got that, right? And then we just brought this one here down. Then when you multiply same bases, see, I've got b to the power 3 times b to the power 3. Then I will have 3 plus 3 is 6, and 1 times a squared is 1a squared. That's your final answer. Once again, we do number 5a, right? Let's go to b. Okay, right? So here we can't what can I say, strike off like this 3a. Okay, some learners, what they do is they look at this 3 and say, you know what, let's strike off this 3 and let's take it out from this 27 over here, right? No, you can't do that, because see, you also still got this 9 here, right? So what you need to do, you need to split this up. You see, wherever there's an operator there, like a plus or a minus sign, in this case this is a plus sign. Now we need to say 27a over 3 to the power of 3a. We got that first part, positive sign. Then there's our 9a, and we got our denominator there. Now we are very used to moving from this step to this step. Now in fact we're moving from this step to this step here. Then what we're doing in fact from here to here is that we're finding our prime bases now, right? And I told you that the shortcut way to do this, if we're not too sharp in a manual method, sorry, with those manual methods there, we can say 27 is equal to shift fact 3 to the power. 9 is equal to, let's get that, 9 is equal to shift fact 3 square. That's how we move from there to there, there to there. Then we can see that the a is outside the bracket, so you can say 3 times a is 3a, 2 times a 2a, right? So we simplified there. Then we've got the same thing here, cancel off. It's 1 over 1 is still 1, right? All right, then here okay, If I've got 3 to the power of 2a divided by 3 to the power of 3a, I hope we can see that we're going to have something like a 2a sorry, okay, this is not working out properly there. Okay, let me explain it this way then. All right. Oh, okay, let's do this. Which is the bigger power? Here, this is bigger than that. By how much? By 1. Just 1a. So we write our 1a there. Right? Many learners like to use that method there. The other method I was trying to show here was 2a minus 3a will give me a negative a. Right? Answer would be negative a. If I have it like that. This is the same thing like saying negative, I'm sorry, 3 to the power of negative a over 1. Change it to make it a positive power. There we go, 1 over 3a. So that's how they move from here to here. There's two different ways of looking at it. Most learners like to use the method and say, you know what, which one is the bigger power? This, by how much? By 1. And that's what learners do, right? Okay, so yes, that's B. Let's go on to C. C, okay, 6 minutes. Okay, here we need to, okay, let me zoom in a lot here because I want you to see something, right? I want you to see that this 3 is going to be multiplied by this n squared. This 3 is going to be multiplied by m and by 3. There are 1, 2, 3 parts there. The number 3, the m, and the n squared. And there are 3 things in there. Here, there are 2 things in there. Right? So, let's just get this answer in there. Sorry. Okay, let's look at this now. Now that we can see that 3 to the power of 3, 27. Don't believe me? 3 to the power of 3, 27, right? So m to the power, okay, we have got m to the power of 1. 1 times 3, 3. Now we've got n to the power of 2. 2 times 3, 6. Then 4. Whoa, something went wrong here in the memo. Okay, something is wrong here. Oh no, okay, they already simplified it. Sorry, my mistake. 4 squared. Okay, let me show you what happened. Right, you had a division sign here, so they turned it into a multiplication sign. When you do that, you got to flip this. Top part needs to go at the bottom. Bottom part needs to go on the top. So this, the answer is here, right? So 4 squared is 16 and m squared, so we can have 2 times 2, m to the power of 4. This went to the top. Remember, n to the power of 0, anything to the power of 0 is 1. So like this times 1, it splits itself, right? Okay, then we simplify. Now you can do this many different ways, right? Yeah, let's look at this here. Let's try 8 over 27. 8 over 27. We can't really simplify things, right? They're skipping a lot of steps in here. Okay, let me try and write out what I need you to see, right? Okay, the easiest way that most learners find to do this is to multiply the whole thing out first, and then step by step have your constants column, your m column, and your n column, and then get your answer. Let's do that now, right? 8 times 9. 8 times 9 we got there, 72. So we're gonna have 72. Then we've got m squared times m to the power of 5. That's m to the power of 5 plus 2, 7. Then we've got n no other ends there, so n to the power 3 all over. 27 times 16, sorry, I said 27, 4 3 2, and then okay, without m's, 3 plus 4 7, okay, n no partner, n to power 6. There we go. How do I change this color? I just want to show you here. Okay, let's just go over this here for now. I think you can see. Then we've got this here. I hope you can see that this is 72 over 432. Over 6, right? So we've now can simplify this to 1 over 6. So we finished with our numbers, with our constants. This is what I was talking about. When you simplify, you got that. Then we got m7, m's are out here with our n's. Which is the bigger power? N to the power 6. By how much? By 3, right? Then we can write this out neatly to present our answer. 6 n 3. 3 didn't look neat enough. N to the power 3. There we go. Same thing, right? Let's go to E and let's try and speed up. Okay, same story, we split it up, right? Okay, all right, same story, we split that up. Now you may be thinking, sir, where did they get this from 80? How did they turn that to 2 to the power 4 times 5 all to the power of p? Let's look at this. This was 80 to the power of p, so that 80 changed into whatever you see in the bracket. Let's look at this now. 80 is equal, sorry, there we go, 80 is equal to shift fact. There we go, that's right there. Same story, let's try this with a 96. 96 is equal to 96 shift fact. There we go again. Let's show the p there, right, there we go. Right, same story, the 48 and the 48 there again. Okay, all right, then we've got that there. Let's look at this step here now. All right, so we can see now we move from this step here to here. All we did was we put our p's. P must join into each one. Same story with this top one, this one, and this one here, right? And we simplified to that. Then I know this looks chaotic. Now we cannot do things like multiply the whole top, multiply the whole bottom, because we have an addition sign here. We can't do that. So let's do this first part here. We can cancel that. Now I've got a 5p. And I've got, okay, this will turn into 1 and 1, and so we don't even consider it now, right? So this will turn into 5p, 3p. Now why can't I say, hey, you know what, let's just make it 5 over 3 and let's figure out p's, because they will cancel out each other. They will not. Reason being, when we divide, remember we said when you divide and we have, if we have the same bases, then we can subtract our exponents. But in this case, we don't have the same base. We have 5 and we have 3. So therefore, we got to take the whole thing down. The whole thing. So from this here, we brought that down there. There's my plus sign. This cancelled off this here. Here we have same bases. Here we have the same bases. So we can subtract our exponents. We can say to ourselves, 5p minus 4p is equal to just p, right? 5 minus 4, just 1p, right? So that's how they've got that p. Okay, let's see. All right. Okay, there's many, not many. You can use manual methods here, right? So when you're dealing with what is it called, scientific notation, right? When you're dealing with scientific notation, your job is to get this point. Let's just zoom into this point. Is to get this point here. Here meaning where you've got one digit to the left of it, and then the rest of the digits can go to the right of it, right? If we look at this last example here, my job is to get this point here. One digit is to my left, and then everything else is that side. Can you see that? Can you see that? Now, I need to move. Let's count. 1, 2, 3, 4, right? So that's why I put my -4. So you can remember, if negative, if you're going right to the right, if you're moving this here 1, 2, 3, 4 to the right, you can put a negative there, right? That's a manual method you can use. Even here, when you're faced with this, remember your comma is here, or your point is there. Why did this get so small? Okay, my point is there. Then we need to move from there. Let's count. 1, 2, 3, 4, 5, 6, 7. Remember, I said I want this point here where I've got 1 to the left and everything else is there. I want it like that. So I moved again. 1, 2, 3, 4, 5, 6, 7. That's how I got 10 to the power positive 7. So you can remember, if you're moving left, you've got a positive exponent, right? That's a manual method. Now, I don't suggest you do this, but just for knowledge sake, you can do that in a calculator as well. Go to shift mode scientific, right? Set it on 9. Set it on 9. Don't worry. I'll show you now. If you've got 3, 2, let's see, 7, 6, 0, 1, 2, 3 is equal to, right? Now, the reason why the calculator asked you from 0 to 9 is because it asked you how many digits you want after your comma. So your calculator is going to give you this answer. Let's look at our final answer. This here is our final answer. The calculator knows that it needs to put the comma here, and it gives you your answer, and then it gives the zeros, 0, 0 after that. So what you do is, when you present your answer, you present only this part here, only this first part, right? Don't present all these zeros. The reason why I gave that is, what if you get a big or many digit number and you need to put that there in, right? You just stop at the 6. Okay, yeah. So that's that. It also works with the other ones. Let's just get this here. Let me try and get both in the screen at the same time. All right, there we go. This will also work if we write in 0.123096 is equal to, there we go, right? 0.96, don't write all the zeros, times 10 to the -4. Now, when you click your calculator back like this, you should see you still got a scientific. So if you type in like 3, just a normal number like 3, and look at what it gives you, right? We don't want that. So we're going to go shift mode and put your calculator back on a normal mode. It'll ask you normal 1 or 2. At this point, I'm not even sure what's the difference, but I always click 1, right? And it's back to normal. 3 is equal to 3. Right, let's get back. I think I need a question for this. Let's get here. Looking at number 7. And these are definitely number patterns. Okay, study the following patterns carefully. Then for each pattern, do the following. Find the next 3 terms. Okay, find the next 3 terms. Write down in words how the pattern works. Okay, most of the time in exams, you don't really get, you might get it one, but not in a final exam. Like maybe in a term 1 exam or something like that. you just get this question. But the famous questions are find the next three terms. This you'll even get right to metric. We've got find the 10th term. Okay, right, there's an expression for the pattern. Right, now most learners find this one here easy, to find the next three terms. Find the next three terms is generally easy, right? Write down in words, right? That day I'm not really tackling in too much of detail today. Everyone can use their own words. Find the 10th term of the pattern. Now this, let's see, we got to go 1, 2, 3, 4. They already gave us. We're gonna have 5, 6, 7, 8. So from the 8th term to the 10th term, it's easy. You can make your jump there. Where learners have trouble is to write an algebraic expression for the pattern. That is where there's trouble. So let us focus and zoom in on that. Right. All right. Oh, they gave us a number pattern here as well. Okay, very good. So let's look at this one here. At this first number pattern here, we've got 1, 4, 9, 16. Let's see. Between let's see if we get a constant difference here, right? Constant difference, we can have 3. 1 plus 3 is 4. Then here we can have 4 plus 5 is 9. Hey, I had a plus 3. Let's try. I can write it down. Plus 3, and here I've got a plus 5. So let's see. I definitely don't have a constant difference. I don't have a constant difference. Then I can't have a constant difference. Do I have a constant ratio? Let's see. 1 times 4 will get me 4. That's good. Then if I say times 4 again here, 4 times 4 is 16, but we got 9. So definitely we don't have a constant ratio. Then what can we have then? This is a special one. Let's see. Let's start with our squared. If I say this is my first term, this is, let me just get some space. This is known as term 1, term 2, term 3, and term 4. So let's try something called n squared. Right? Let's try n squared. Meaning 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Hey, we figured out like a rule for this. Can we see that? And then we're saying, hey, this is going to be my, this 25, 36, and 49 goes thereafter. So this was term number 5, 6, and 7. Let's look at it. 5 squared, 25, 6 squared, etc. It's easy to get the next one. 10 for the 10th term, 10 squared, 100. Sort it out. Then they ask you to write that down. Wait, this is an algebraic expression. Supposed to be Tn. This is supposed to be Tn. Let's check it. There's an error on the memo. Tn is equal to n squared. Right? So what it means, how you read this out? Term number n is equal to n squared. So for example, if you say term number 2 is equal to 2 squared, which is 4. If I say term number 3, I say T3, so this 3 didn't come out neatly. T3 is equal to 3 squared. So we're going to say T3 is equal to, term 3 is equal to 3 squared is 9. So term 3 is equal to 9. There we go. Can we see that? Alright, perfect. Let's go to the next one. Oops, sorry. Let's go to the next one here. Now, between this 7 and 11, I've got 4. Let me try and zoom in. I've got a positive 4. Between 11 and 15, positive 4. 15, 16, 17, 18, 19. Can we see that? We added 4. So hey, we definitely got a difference here. So we talk about constant difference. So obviously to get this is my term number 1, term number 2, 3, 4, term number 5, 6, 7, right? Okay, yeah, they wrote it out in words, right? And 7, and yes, you can go we went, yeah, term 7, 8, 9 and 10, and you can get your 43. You can do it that way. But if we didn't have to realize this equation as yet. Let's look at how they created this equation. I want you to think about this. Let me see if I can change my pen color without changing that. I have to change that. Okay. I can't get red back. Whatever. Okay, apologize for that. Let's take this out because I want you now. Okay, we know that the constant difference is +4. Let me just write this down here so we don't forget, right? We know the constant difference is +4. Now this is term 1, this is term 2, term 3, term 4, term 5, 6 and 7. Now to make my equation, we know our constant difference is 4, right? I want you to see how they created this equation. I'm referring to this part here. My constant difference went here, something times n. My constant difference in this case is 4, so it's 4n. And then I've got a +3. How would I know what goes there? Yes, you can do the method where you can say, hey, you know what, 4n plus something will get me my next term. All right, so let's try, and if we say 4n for term 1, 4 times 1 is 4, right? But I need 7, so I needed to add 3. So that's how you can get your +3. You can fill it in and you got that. Now the right way to do that is to get something called a term 0. You know that you're adding 4 here. So obviously between 1 and term 2 we add 4. Between term 2 and term 3 we got to add 4 to go to the right. Now if you're going backwards, right, meaning between term 0 and 1 I'm going to have +4. So I need to realize, you know what, I'm going to have 7 minus 4 will give me 3 here. Can we see that? Can we see that term number 0 is going to be 3? So term number 0 gets in there. Can you see that it's a +3? That's why it's a +3 there. That's how you create your equation. Once you create your equation, you chop off most problems that you're gonna encounter in number patterns. All right. Okay. This is actually a repeat question. This is also addition. You got to add 7 to the previous term. Add 7. So I'm not going to show that. Obviously, if you're going to be adding 7, you know your term Z. This was term 1, term 2, term 3, 4, etc. The 3 didn't come out neatly, etc. I need to find term 0. So 8 minus 7 will get me +1. That's how this went there, and this +1 went there. That's what I'm talking about, right? So we got that. The rest I'm sure that you can sort this here out, right? Okay. This was a bit tricky. Number 8, right? Number 8 looks chaotic, but if you use the same basis how I showed you this, if you use the same basis here, it's going to be a walk in the park. Let's try and zoom in suitably. Okay, all right, let's look at this now. Let's check this out. Let us I hope you know this. Once we figure out the rule, once we determine this rule, we can fill out anything we feel like, right? So let us find, see here, we need to find our constant difference goes next to the end there, and my term 0 goes at the end. My term 0, there's it there. It's a +3. There's that +3. It's there, right? Now, remember the answers are in red, so those things should have been blank to you. Now you'll have to try and figure out, hey, you know what? I need to find my constant difference. What is the difference between this 8 and 3? Right? Now, if I'm moving this way here now, 8. Oh, sorry. How do I turn that out? There we go. 8 minus 5. This is coming untidy. 8 minus 5 will give me 3. See, I got -1, 0, 1. See, I'm stepping in 1 here. I'm stepping in 1. Now, 8 minus 5 will give me 3. 3 minus 5 will give me -2. So I hope you realize, see even here, 13 minus 5 will give me 8. I hope you realize that I've got a constant difference of 5. Therefore, I put my -5m. My term 0 was 3. Let me zoom out so you can see. Term 0 was 3, so I put the 3 there. Once I have that, I could sort this out easily. Right? Then let us see. Okay, same story, except here. Right. Okay, no, it didn't give you C to do. I gave you D. Same story, exact same methods I'm talking about. Exact same. We need to figure out the difference. Here we added 9. We realized constant difference is we adding 9. -2 is our 0 value. There's it there. Let's see what else we have here. Number 9. Okay, now people, some learners are going to find this section here an easy section. Some learners are going to find this a hard section. Now, okay, good that this memo does it the exact way that I do it as well. Now, they told you, see this, they're telling you if A is equal to 3, if B is equal to -5, and if C is equal to 10, D is equal to -2. Find the value for the following. They should be telling you that for the following year. So what you're going to do is, wherever you see this alphabet, take it out and replace it with a bracketed value. Meaning, for C was 10. You didn't have to put the brackets, but when you're starting off, let's keep our brackets there, right? These are brackets. Then, for B value was -5. My D value -2. Can you see I put my -5 into a bracket? Let's just zoom in so you can see clearly. Can you see this -5 is in the bracket, -2 is in the bracket. My value here, which is A squared, value for A squared, value for A is supposed to be 3, right? So I take out the A, and I put in 3 in brackets, right? Now watch that, the square is out of it, because I took out only the A, and I put the 3 there, and then the square is out of my brackets. In this specific case, I can't really show you what that means, but please follow these methods that I'm showing you, right? Because if you have a negative, then that'll greatly affect you. Okay, yeah, and then that's it. The normal, between the normal stuff that we're doing on top, right? Same story here. Let's get to B. Sorry, there. Oh man. All right, there we go. So C, we got there. Can you see how we plug in these values, right? And then we simplify thereafter. Simplify. Whenever you don't know what to do next, please refer to your board mass. Please refer to your, let's put that in caps, to your board mass, right? So if you don't know brackets, within your bracket, is everything simplified? So you check within your brackets, you gotta simplify this, right? Then is your orders. Can you see that we are next? Our orders, 10 squared, there we go, -2 squared, there we go, etc, etc. Then we got our division, multiplication, addition, and subtraction. We just do our normal board mass there. Let's check. Pretty straightforward. Okay, the video is going quite long. Okay, that there. Let's check. Okay, number 10, you get the answers are right. These are quite easy ones from grade 8, right? Okay, I'll have to maybe stop this video here. Alright, I'll have to stop this video here. Thank you.